Good evening, grade 9s. I'm just getting a little video together here. Hope you guys enjoy your long weekend. We'll get back to this on Tuesday. But we had a couple questions, so I can fit the first 3 on here, and we'll look at number 10 after this. So these are from 5.2. So the first question says identify the slope and y-intercept for each line. So when we are looking at an equation that's in the form y equals mx plus b, our slope is going to be the m, and the y-intercept is going to be our b. Since these two equations are currently in standard form, we can't really see that information. So what we're going to do is we're going to switch it around. So in order to do that, I'm going to move the x and that minus 3 to the other side of the equation. Okay, and our last step is to divide everything by 3. So we have y equals negative x over 3 plus 1. So we can see here that our y-intercept is 1. Our slope isn't as obvious. Negative x over 3 means the same as negative 1 over 3x. So I think that makes it a little bit easier to see, just kind of switching it up a little bit. So it's still equal. And the number in front of the x is going to be our slope. So our slope is negative 1/3. Our y-intercept is 1. We're going to do the same kind of thing here. I'm going to do this one a little backwards because I see we've got a negative coefficient in front of the y, so I feel like let's move this one around. Let's see what happens. So we have 2x plus 8 is 5y, and from here we can divide everything by 5. And we're okay leaving it as fractions. We don't really need to switch it to a decimal here, even though we could, because these aren't going to give us repeating decimals. But yeah, we've got our y on the right side of the equation, but we still have our mx and our b. So here would be our slope, and here would be our y-intercept, which is also our b. Okay, so that's all we had to do in the first one, is switch into our slope y-intercept form. 6, there was a lot of writing there. I'm not going to copy it all down, but this one was talking about the earnings for a worker, and based on the number of years they've worked, we could calculate their earnings using this equation. So if we were going to calculate for the earnings, we might want to have that one by itself in this equation, and this one, we can do that fairly easily by moving that to the other side, and then that would leave us with n plus 15 is equal to E. So a beginning worker would have 0 years of experience. So we'd have 0 plus 15 is E for that beginning worker. So 15, that would be the starting wage for the beginning worker. For the 5-year worker, we'd have 5 plus 15 is E, so $20 an hour for the worker who's been working there for 5 years. Okay? So yeah, a lot of writing in that one, but essentially that's what we're doing. We're rearranging the equation to get a variable isolated and then subbing in some values. Number 7, we are given an equation that deals with temperatures. So we've got Celsius, Fahrenheit, and our constant added in there. So this one said express in the form C equals MF plus B. That's a fancy way of saying get the C by itself. Okay, so we're going to do that. We have 9C. I'm going to move these guys to this side of the equation. So that negative 5 is going to be 5F. And this is a big C, so I'll put that in there. Minus 160, because that's got to switch as well. And then our last step to just get that Celsius by itself. And this is our equation here. Okay, so in this case, our slope would be 5 over 9, and our y-intercept would be negative 160 over 9. Now, this is not something I would ask you to graph on a regular basis. This looks pretty messy with this starting y-intercept. So that's, what's that roughly? It's negative 17 or 18. So I'd have to punch that in the calculator. But just for a quick sketch here, we will go way down to our negative 160 over 9, whatever that's equal to. And we'd use our slope of 5 over 9 to graph this. Okay, so from here we could go up 5 over 9, up 5 over 9, up 5 over 9, up 5 over 9. Okay, we could use that slope of 5 over 9. So our rises were 5, our run was 9, to get a good graph of this relationship here. Okay, so this is just a quick sketch. I don't know how accurate this even is, because this would be probably pretty far down on the y-axis. And lastly, what do the slope and c-intercept mean in this case? So in this case, this negative 160 over 9 is representing the temperature in degrees Celsius when Fahrenheit is 0. Okay, so when Fahrenheit is 0 degrees, this is going to be our temperature in degrees Celsius. The slope in this case is telling us how much the Celsius is rising for every degree Fahrenheit being added. Okay, so it's kind of giving us a slope here for how Celsius and Fahrenheit are related and how their temperatures work together here. Okay, so I'm going to pause here and I'll get number 10 right up on the board. All right, let's try something cool here. All right, here's number 10. I'm going to actually press record this time. I'm just talking to the walls for a little while, but not much else is new. All right, let's take a look at number 10. So number 10, we are given two different companies that are offering their banquet halls for some events. We have these two equations that we're given. First thing we're asked is to express in slope y-intercept form. So in this case, if we want to identify our dependent and independent variable, our dependent variable is going to be the cost. The cost is going to depend on our number of guests. Okay, so we want to get the c by itself, because we always have that y value by itself. So in this case, the c is in place of our y. Okay, and this can be an easy thing to do because our c can just get brought over to the other side in both of these equations. So for the nights, we will have 25n plus 1250 is c. And for Legion, we'll have 30n plus 995 is equal to c. Okay, so a fairly easy first step. They're negative already, so when you switch them over, we get two positive c values. In B, we're asked for a fixed and variable cost. So the fixed cost is something that's never going to change. And in this case, for nights, it's going to be that cost of $1,250. So this is maybe like a booking or reservation fee that they charge. And then Legion is going to have a lower fixed cost of $995. The variable costs for nights it's going to be $25 per person, and it's going to be $30 per person for the Legion banquet hall. So our next question is asking us, what is the cost for 45 people? So that is going to be going in for our n variable. So for nights, we'll have 25 times 45 plus 1250 equals C. And here we'll have 30. All right, where did I put my calculator here? Oh, there she is. All right, so I'll calculate these out for you guys, or press pause and do it yourself. Follow along here. Okay, our first one, if my calculations are correct here, we've got $2,375. And for our second, 30 times 45 plus 995, $2,345 for the cost for the Legion Banquet Hall. So, which one offers a better price? Looking at this, Legion offers the better price for 45 guests. But one thing we need to consider here, is Legion always going to be better? And when is it not going to be better? Okay, so we're going to do a lot more calculations like that in your grade 10 course. So we'll get into questions like that a little bit more. But just to give you a little visual of what's going on here, if I were to just sketch out these two relationships. Our first one, it has the higher y-intercept, but it has a smaller rate of change, or a less steep slope. This one has a lower y-intercept, but a steeper rate of change. So I'm going to just sketch two lines on here. And in my sketch here, let's say that this is at 995 and this is, okay, 1250. So we can see here that the Legion Banquet Hall starts lower, but eventually is going to cross. Our Knights Banquet Hall starts higher, but has a lower cost per person, so eventually it's going to be the better deal. Okay, so if you have this thing rented out to max capacity, maybe we're on the other side of this point here, and that's going to make the Knights Banquet Hall a better deal. All right, have yourself a good long weekend. We'll get back at it soon. Talk to you later.